Alright, one more example. We're going to want to find the square root of this complex number. Finding square roots, or finding any root or any power of a complex number, is often easier if you had it in polar form, which we're not going to do this time, but just showing you. Because if I have polar form, for example, if I have 4 cis pi over 3, and I want to square root that, the square root of r is going to be the square root of 4 cis of pi over 3 times a half. Okay, so I just get 2 cis pi over 6. Okay, square roots are very easy with this. So you might think that you could convert this into polar form and then do this step and then put it back into standard form, but this minus 7 and 24 is not going to give us a nice simple number like this. It's going to basically be a decimal. So there's going to be some rounding, whereas actually we can solve this one exactly. Okay, so here's how we're going to do it. So forget all this polar form stuff. We're going to say that this equals a plus bi. Okay, so we've got some complex number, a plus bi. When we square it, we're going to get this. So that means that a plus bi squared equals minus 7 plus 24i. Okay, a plus bi squared is, I'll just go step by step, a plus bi times a plus bi, which is a squared. The real part is the a times the a, and the bi times the bi, which becomes minus b squared because of the I squared. We're going to have an a times bi, and we're going to have two of those. Okay, 2ab I. Okay, so this is the real part, this is the imaginary part. Okay, and this has to equal minus 7 plus 24i. Okay, where this is the real, this is the imaginary. If two complex numbers are equal, the reals have to equal the reals, and the imaginaries have to equal the imaginaries. So we've got a squared minus b squared has to be equal to minus 7. 2ab has to equal 24. Okay, so basically we've got sort of simultaneous equations. We've got squares and times. It's not, you can't use matrices here, but let's rearrange this equation here. Let's divide by 2a, and I'm going to get b equals 12 over a. Okay, and this one I will then sub back into this b here. So I'm going to get a squared minus 12 over a squared equals minus 7. Let's multiply, let's square this part. So we get 144 over a squared equals minus 7. Okay, we don't want anything in the denominator here, that's just messy, so we get rid of that denominator by timesing everything in this equation by a squared, which gives us a to the power of 4, that's the a squared times a squared. When we take this term by the a squared, all it does is get rid of the denominator. On the right side, we're timesing the minus 7 by this. Okay, let's move this part to the other side. So we get, it becomes a plus. Still got the minus 144, and left with 0 on the right. Okay, so this is a factorizing one, which is a little bit, the numbers are kind of big, but just remember that 144 is 16 times 9, which is convenient because the difference between 16 and 9 is 7. So this factorizes to this, okay? Minus 9 equals 0. Alright, so we could go on and factorize this as we've been doing, where we'd get two answers here and two answers there. But we actually are not going to use these two answers here. And if you want to pause for a minute and think about why that is, and then replay. You paused? Good. Okay. The reason we don't use these is because this will give you a complex number. And of course that should have been a squared. This will give you a as 4i or minus 4i. And when you write a complex number a plus bi, you're assuming that these a and these b are real numbers. Okay. So no solution to that part. But to this part we get a equals 3 or minus 3. So b is 12 over a. So if a is 3, b is 12 over 3 is 4. If a is minus 3, then b equals minus 4. Okay, so we've got two answers, which makes sense. I think I explained before that if you do a square root, or if you do a square root of any number, even a non-complex number, if you do the square root of 4, really there are two answers. The square root of 4 could be 2 or minus 2. We just generally stick to using 1. But the square root of this is 3 plus bi, sorry, 3 plus 4i, or minus 3 minus 4i, and done.